Okay. Okay, anyone can hear us? All of our audience? Hello? Okay. I've already see that to some of people have already entered our meeting room. Okay. Hello, everyone. Hello.
Hello.
Okay. Let's wait for 1 minute to see if anyone still entering our meeting room. Hold on 1 second, please. We will start our webinar today. Okay, so if anyone who's waiting, you can see that in our chat box. There's our contact, our website, our YouTube channel. If you're interested in us, you can subscribe. You can check our website for more information. Okay, ready? Okay.
Okay.
Yeah.
I'm ready to.
If everyone is ready, then we will start our webinar today.
Okay.
Okay. So hello everyone.
Hello, everyone.
Hello. Yeah. Welcome to today's HFM Hoffman webinar. I'm today's host, Susanna. Nice to meet you. Yeah. And here next to me is Sophia, our main speaker today.
Okay, nice to meet you.
Yeah. Hello, everyone. And we are very happy to discuss with you a very interesting and also important topic today, how to enhance the efficiency of power plant with heat exchangers. And as global energy demand continues to grow, that improving the operation efficiency of power plant is becoming more and more crucial today. And yeah, okay, I know that some of you already knows us, but some of you are still new to us. So, okay, I will give you a brief introduction about HFM. Yeah. Okay, so who we are, Huffman is a global brand that specializes in designing, producing, and also manufacturing and supplying all kinds of heat exchanger, especially plate type heat exchangers. And we are able to supply different kinds of plate type heat exchangers. And we already have more than 3 decades expertise experience in this field. And we also have our technical team providing professional supports. And in the following time today, we will explore in depth how to and how plate heat exchanger can improve in the heat exchange efficiency and reduce energy consumption, also play an important role in all aspects in the power industry. Okay, today's webinar is not just an opportunity for technical sharing, but also an important opportunity to communicate with each other and also for learning. So if you have any questions about heat exchangers in this process, please feel free to ask us any question that you have, and you can send us message in the chat box. And also we will reply you after maybe in the end, the Q&A section at the end of the webinar today. Okay. So
Okay.
thank you again for attending. Thank you all for your participation today. And now let's start our discussion today. Okay,
Okay.
Sophia.
So let's start this webinar. And hello, everyone. I'm today's speaker, Sophia, and I'm very happy to be here, and I'm very happy to see all of you. And once again, thank you, Susanna, for your introduction, and thank you, everyone, for joining us today. So before we go into the main topic today, I have some questions to ask you. Have you ever used plate heat exchangers in your work? And how do you feel that the heat exchangers can improve efficiency? And I know that many of you know what heat exchanger is and also know how it functions. But before we start our main topic today, I will still briefly go through the basics of heat exchanger. So as you can see, there are common types of heat exchangers. And the first is the gasketed plate heat exchanger and brazed plate heat exchanger, or welded plate heat exchanger. And HFM provides these three types of the heat exchangers instead of the shell and tube heat exchanger and the tube bundle. And as you can see, here is the small plate heat exchanger model in my hand. And here.
Okay.
Okay. So here is the fixed plate. And on the opposite is the moved plate. You can see it here. And in the middle, in the middle, there is heat exchanger plate. It is the heart of the plate heat exchangers. And on the top of the plate heat exchanger is the upper guide beam, is here. And on the bottom is the lower guide beam. And there's also a back pillar and a footing to make the plate heat exchanger become more stable. And there's also a clamping bolt on here to fasten the plates together. Yeah. Okay.
Give it to me.
Okay.
Yeah. I'll put it here.
So before we dive into the power plant process, Susanna, do you feel what are the most critical rules that heat exchanger plays in these processes?
Well, I know that a lot of waste heat is generated during the operation of the power plant. So if the waste heat, also the heat cannot be used effectively, it will waste energy. Therefore, I think using heat exchangers can reduce this part of the heat.
Yeah.
And also in the process of power generation, the operation of turbines and also generator will generate a lot of heat. And the cooling system is needed to maintain the normal operating temperature of the equipment. And
Yes.
yeah, so plate exchanger is used in the cooling system and effectively to control the temperature of the equipment to ensure a long-term and stable operation condition of the equipment.
Okay, thank you.
Yep.
Yeah, the point she just mentioned is very important. And indeed, during the operation of the power plants, waste heat recovery and cooling systems play an important role. And if there's no cooling system, long-term overheating operation and temperature fluctuations will not only reduce the operating efficiency and increase operating costs, but may also cause the safety accidents in severe cases. So now let's move on to the part one. And in this part, we will talk about two things. First is the full power plant processes. And they may involve the heat exchangers, but not specifically the plate type heat exchanger. And in the second part, we will talk about the plate type heat exchangers functions in power plant. And for your information, since every power plant is different in their size, design, cooling method, and even their types. So we just giving the illustration and the example for the general coal-fired power plant. And in the real life situation, you know, every power plant is different. So on this page, here's the full cycle of the power plant processes. And we start off we'll start again by the top of this slide. So as you can see, here's the fossil fuel power plants, and they will burn coal natural gas, and oil to produce steam. And this steam will drive a turbine and a generator to produce electricity to the power network. And here's the steam condenser. As you can see, the water is pumped into the low pressure reheater for heating. Oh no, sorry. A steam condenser is used to cool down the steam and its heat to transfer its heat to the cooling medium, such as the water or air. And the steam is then condensed back to the water. Yeah. And in the bottom of this page, you can see the water is pumped into the low pressure reheater and passes through the deaerator to remove oxygen and then heated by the high pressure reheater. And what about the waste gas gun? And you can see in the right of this page, the waste gas is discharged through the chimney after being treated by the devices such as the dust collector and into the clean gas. And the furnace slag is then transported to the ash yard. So here's the full cycle of power plant processes. And in some of the events, it involves heat exchanger, but normally it's the shell and tube heat exchanger for condense and reheat purpose. And in the next part, we will talk about the function of plate heat exchanger in power plant. So this diagram shows the cooling systems used in the power plant. And as you can see, here's the two main cooling water circulation system. One is the open loop cooling water circulation system, and the other is the closed loop cooling water circulation system. And we are gonna begin with the open loop cooling water circulation system. And the water source comes from a cooling tower, river, or lake, and is pumped into the cooling tower for evaporation of the water. And the cooling tower replenishes the water source to ensure the continuous operation of the cooling system. And as for the closed loop cooling water circulation system, the water has been desalinated and is used and circulated through the pump and the plate heat exchanger and to regulate the temperature of the equipment. And in this system, there's also a water replenishment section to ensure the sufficient water. And in addition, there are different coolers are used to cool the oil and water of the various equipment of the power plant. And they may including the main engine oil cooler, vacuum pump oil cooler, stator water cooler, and others. And these cooling systems and equipment work in tandem to ensure the efficient and safe operation of the equipment in the power plant. So on this page, we show the plate materials used in different types of plate heat exchangers. And the first, the cooling loop water plate heat exchanger used the 304 or 304L and 316 or 316L stainless steel as the material. And this type of plate heat exchanger is mainly used for closed circuit cooling systems with flow or treated water, and is for general organic and inorganic media. And the use of the stainless steel ensures that the heat exchanger maintains good corrosion resistance and stability under a wide range of cooling conditions. So the material used for the open loop cooling water system is the titanium, because the open loop cooling water system are usually used the seawater or river water, which is highly corrosive, and the titanium is chosen by its extremely resistant to the corrosion, which can effectively prevent the damage caused by the corrosion and ensure the long-term stable operation of the plate heat exchangers. So the last one comes to the oil cooling systems. And the oil cooling system material is stainless steel or aluminum or copper alloy because the oil cooling systems requires the high structure stability and the stainless steel, aluminum, and the copper alloy can provide good strength, and the aluminum is suitable for low temperature, while stainless steel provides better protection against oil leakage and the contamination. So by choosing those materials precisely, we ensure that each heat exchanger provides optimal performance and durability in specific operating conditions. So in part two, we will talk about some problems in the installation process. So now I have a question for you, Susanna. So have you ever encountered the cases where a plate heat exchanger's performance has deteriorated due to the installation problem? And how can this problem be avoided?
Well, I do have experience that I used to come across a client who installed the heat exchanger gaskets in an improper way. So this caused that his heat exchanger is totally damaged and also occurred severe leakage. So during the installation process, it's really important to ensure that there's no damage or improper displacement during the installation process. Yeah.
Yeah, okay, thank you.
Yeah.
So absolutely, she just mentioned a typically problem that often happens. But there are also many other problems that will happen about the plate heat exchangers. So I will go through this with you one by one. So the first problem is the installation problem. The improper installation may lead to the unstable or inefficient operation of the equipment, and this may affecting the performance of the entire heat exchanger. And how can we solve it? We must ensure that the equipment is inspected and aligned and tested before and after installation, and that the condition of cells and fixings is regularly checked to prevent improper installation and long-term operational problems. And as you can see in the picture, here's the internal leaking. And the internal leaking is refers to the pore sealing between each channel inside the heat exchanger, which leads to the leakage of heat medium and affects the heat exchange effect and the system safety. And we can solve it through use heat and pressure resistant cells. And we can regularly inspect and replace the deteriorated parts and design leak detection system to repair problems in a timely manner. So here's the video, and you can see it's a typical external leaking. And the external leaking may involve leakage from the part of the heat exchanger that is connected to the external system, and which may due to the problems about the components such as pipe joints or sealing gaskets. So we can prevent external leaking by selecting the corrosion and high pressure resistance materials and ensuring the quality of connection cells and regularly checking and maintaining the integrity of heat exchanger and piping. So the next problem is the falling and scalding problem. Because the flow paths inside the plate heat exchanger may become clogged due to the deposits or impurities, impeding the fluid flow and reducing the heat transfer efficiency. And especially at high temperature and high pressure, or with fluids containing minerals, the surface of the heat exchangers is prone to falling, which may affect the heat exchanger and leads to the reduction in energy efficiency. So we can solve it through regular cleaning of heat exchangers, and we can using the filters and inline inspection systems, design of self-cleaning features, and control of water quality to minimize the risk of clogging and scalding. So the last problem is the plate damage. The plate damage is usually due to the mechanical collision and corrosion or overloaded operation, and the plate may be damaged, and the result may become to the leakage or performance degradation or the need of the replacement parts. So it is important to focus on the selection of corrosion resistant, high temperature and high pressure resistant materials, and consideration of plate strength design so that we can solve it.
Okay, great. Before we step to the pulse rate, I want to talk about the things that we just mentioned. So Sophia, you just mentioned a lot of problems that will occur in our installation process, right?
Yes.
Such as internal leaking, external leaking, clogging, and also scaling.
Yeah.
So I want to ask all of our audience to think about that. Have you ever faced this kind of problem if you have experience using plate heat exchangers? I want to know that if you have any ever taken any measure such as cleaning or any other preventive measure. And if you have such story or experience that you want to share with us, you can send message in the chat box, and maybe we can share your story later.
Okay.
Okay, Sophia, next step to the next part.
So, okay. So the next part is about some maintenance tips and precaution. So normally we will get some inquiries regarding the maintenance or service request during our work. And this question is related to the plate heat exchanger in power plant. So in the part 3, we will focus on some basic maintenance tips. And here are some tips we want to share. But before we share these tips, Susanna, do you have some tips to share with us?
My tip?
Yeah.
I strongly suggest that everyone you should ask for professionals for help. Okay.
Okay, great answer. Yes, we should definitely ask for expert help, especially in some problems that are very tricky. And yes, you can also consult us and contact us on the telephone or email or the website so that we can provide you the best solution. So here are some tips about installation I want to share with you. First, do not over tighten the plates, and we suggest you to consult for the expert service. And here's the formulas about the plate thickness and corrugation depths to help to determine the correct location and pressure to install the plates. But please note that it's only a general guidance, and in a real world application might be different, and it is based on the model and your condition. And second, use proper tools and take safety precautions to secure our personnel and equipment. And finally, conduct leak tests after the installation so that it can ensure the leak tightness and safe operation of the equipment. Also, here are some tips about maintenance. First, certain malfunctions can be observed, such as the external leakage. So once you observe these malfunctions, you can check it regularly and dealt with in a timely manner. And next is perform maintenance regularly and avoid malfunctions or performance degradation due to the negligence of people. And when replacing the gasket, we advise you to replace the whole set to ensure sailing performance and long-term stability of the equipment. And when checking the plates, we also advise to conduct a penetration test to ensure that the plate is not damaged or cracked.
Okay, great. Thank you, Sophia, for this
Okay.
part to let us know that how to maintain the heat exchangers. So our audience, please review and think about the most common college you have and faced before when using plate heat exchangers. I'm sure that you have already know more about how to solve the problems in the previous part we just talked about.
Yeah.
And also, if you still have other problems that you cannot solve it on your own, you can send emails to us and we will consult and reply you after this webinar. Okay?
Okay.
Okay, great.
So the next session is about the advantage HFM plate heat exchanger of the power plant. So before we go into this part, I have a question to ask you, Susanna.
Okay, another question.
Yeah, another
Okay.
question. So what do you think is the potential of the plate heat exchangers in terms of the energy savings?
Terms energy savings. Okay. So when you talk about energy saving, I think of water conservation.
Water conservation?
Yes. Yes.
Okay.
Okay, because we have a lot of experience about water to water heat exchange, and you know that in many power plants, the cooling water is needed in the circulation system. Okay, so plate type heat exchanger can be more effectively recovered heat from the cooling system and transport it to another fluid, which can reduce the consumption of fresh water and also can extend the using of cooling water.
Okay. Yes, definitely the water conservation is the main advantage of the plate heat exchangers. But I also want to share other advantages that of HFM plate heat exchangers. So the plate heat exchangers provide the high heat transfer efficiency and which helping to reducing the water usage and decreasing the electricity consumption so that thereby improving the overall energy efficiency. And also the plate heat exchangers has more convenient installation and maintenance, which help to effectively reducing the downtime and to ensure the continuous operation of the power plant. And with its small footprint and compact structure, the plate heat exchanger can improving the power plant capacity and space utilization and making it particularly suitable for some environments that with limited space. So I have some questions to ask and to our audience. So what are the most important factors you look for in selecting a heat exchanger for your application? And you can type your opinion on our chat box, and we are looking forward to see your opinion. And so here, HFM has this plate and gasket materials for the plate heat exchangers. So as for the plate material, The first one is the SS304, which is the most widespread and inexpensive material for general organic and inorganic media. For example, the water, the cooking oil and ethanol and others. And the SS316 is suitable for the general organic and inorganic materials. And for example, the water, river water, edible oil, carbonic acid, alcohols, and others. And the titanium is particularly suitable for the seawater or other highly corrosive fluid environments. And others like 254 SMO, titanium, palladium, alloy, and others, we don't show the details. And as for the gasket materials, NBR is resistant to oil, acid, and alkali, and it's very suitable for the general liquid sealing. And another is EPDM, is resistant to the high temperature and oxidation, and it is suitable for the water and steam sealing. And others like FKM and CR and others. So we have discussed the various materials used in plate heat exchangers, such as the plate and gasket materials, and the selection of which is directly related to the performance of the heat exchanger and the environment in which it is applied. So in the next, I'll focus on why choosing the plate heat exchangers instead of the traditional shell and tube heat exchangers in many applications. So especially in terms of the heat transfer efficiency, compact design, and maintenance costs. So first is the plate heat exchanger. Plate design has a larger heat transfer area and it has a smaller fluid passages to help to increase the the heat transfer efficiency. And the plate heat exchanger is more smaller and lighter in weight than the shell and tube heat exchangers. And as you can see, the plate heat exchanger structure allows for easy disassembly of the plates, and it also have lower initial investments costs. And the plate heat exchangers can be increased or decreased according to the need to flexibly adjust the heat transfer capacity to adapt to different flow requirements.
Okay, great. Now we step to the heat exchanger design part. So I will introduce our heat exchanger selector tool for you. Okay. So you can see that this is our self-developed heat exchanger selector tool. That you can see that we have the design part and also validation function here. So most of the heat exchangers that are suitable for your application, you can select your model in this part. And also we have a portal for your, the contact us for portal to ask for further inquiries. And also this selector tool is all for your initial and also some technical support to support you to choosing the models that are not that difficult and you requires the direct result. Okay, then for some of the clients that we have, if you have the project or you need custom design, you have custom design requirement and needed to discuss further and closer with us for technical support, you can contact us directly. Okay, so now I'm going to show you some cases and also projects that we have done before. You can see that here in this part is our reference list. We listed some of the projects that we have done before, and also many different international power projects involving the customers. You can see that the countries, they're from India, Russia, Saudi Arabia, and also from Oman, that we have these kinds of projects and also the heat exchanger solutions that have applied to cover crucial cooling needs, such as you can see that closed cycle cooling and also main engine oil cooler. Okay, so this custom design project is for different regions and also different applications, conditions. Our heat exchanger system are able to operate efficiently, effectively, and they're also running reliable in extreme environment. You can see that in the Oman, in the Oman project we have, it is used the material we choose the titanium. It is because that the working condition is severe. We use titanium as the plate material is to deal with the high salt environment. I don't know if you have remembered that we just mentioned that before in Sophia's part, that we have titanium which can resist the high salt and extreme environment. Okay.
Yeah, and it's suitable for the seawater
Yeah,
or
yes, yes.
other highly corrosive fluid environments.
Yes.
Yeah.
That's why we use the titanium as the material in this project. So you can see that we have, yep, we have custom design and also technical support ability for you. If you have project, you can contact with us. Okay, so overall, yep. Okay, I think it's so much for today's part. So overall, that our products have demonstrated strong capability and also adaptability in different climate and also operating conditions, different kinds of applications to ensure the high efficiency and also reliability of power plant, and also in the cooling system we are always striving to improve our customers' operational efficiency and also the equipment life. So if you have any requirements, please just feel free to contact us anytime. Okay. So
Okay.
here, okay, we can begin the last part. The sixth part is the Q&A section. If you have any question you want to ask us, we can discuss here today. Anyone who have any question, you can send us message in the chat box. Okay, so due to the time limit, maybe we will choose part of the questions to answer, and if you are not chosen, please don't be hurry. We will reply your question one by one after the webinar. We will reply you through email. Okay. Yeah, our email message, our email address is left in the chat box. You please check. Installation tip. This comes by directly from you. Well, some of the power plants, they can buy this directly from us. And also some of the other customers, such as some of the EPC companies, we do not contact the direct end user. They cooperate with us through some EPC company. Any other questions?
Okay, I see one. could you show a little bit more about the small heat exchanger?
Oh, okay. Small heat exchanger here.
Yeah, so thank you. So here's the small heat exchanger, and it's actually consists of a set of the metal plates, and the plates form the fluids channels between them, and you can see here. And the hot and the cold fluids respectively exchanged through this channel. And as you can see, on this plate, here is the 4 hole on this plate. And here's the plate used to, the liquid is go into this hole. Oh, sorry, this.
Yeah, because it's just a little model. And if it's full size, you can see that there's a flange.
Yeah.
And the fluid go in and
go
in and out.
here.
Yeah.
Yeah. And this design can greatly improve the efficiency of the heat exchange. So especially in some situations that need to save the space. And the number of the plates you see here can be increased or decreased as the requirement in order to adapt some changes in the fluoride and heat exchanger. And we can also provide some heat exchangers of different sizes to meet the needs of different working conditions. Yes, thank you.
Okay. Okay. Any other questions? Let me check. How to use the tool Hoffman eShop eShop link. Okay, you can check the YouTube channel that we just send the link before.
Yeah.
Please check. Yeah, there's a guidance and video to show you how to use Hoffman eShop. Yeah, we have a website that is individually running. Yes.
Yeah, so I see the question about the temperature range of cooling loop water plate heat exchanger. Well, it is a good question. So we have just made a case that are related to the cooling loop water plate heat exchanger. And the hot side inlet and outlet temperature we given it's between the 48 to 38 temperature, and the cold side is 33 to 43 temperature. But we have to notice that these values only occur in some case, so it is not suitable for all cases. Yeah.
Okay, I think due to the time limit, there's so much for today.
Okay.
And if some questions that we haven't answered yet, I'm so sorry because it's okay. It's already so much for today. I think we've come to the end. Okay.
Okay.
If there's any other question, you can send us email. Okay.
Okay. So.
Okay, I think it's time to say goodbye.
Okay.
And also welcome that you can attend our next webinar. If you want to attend next time, please follow us on LinkedIn, our company page. Okay?
Okay, so
okay, great.
It's time to say goodbye.
Okay, thank you all. Thank you again for attendance today.
Yeah, thank you all. Bye-bye.
Bye-bye.